Okay, welcome back, and we are now moving to our last panel discussion of the day. The industry is changing rapidly. The transition of refrigerants, digitalization, energy efficiency, and better performing systems are the major trends happening. The HVAC market has had its share of innovation in recent years. And HVAC manufacturers continue to invest in technology and innovation to be champions for a cooler and more sustainable future. In this session, we will explore some of the innovation and technologies. After the presentation, we will have the opportunity to take again some questions, so please submit your question in the Q&A box. I'm going to introduce first our three speakers, and then we will listen to their presentation. Today, on the panel, I'm privileged to be joined by Michael Hamilton. Michael is General Manager, Commercial Sales and South Africa with Sealy International. Michael has an extensive experience and has been working for over 25 years in the HVAC industry. Michael, welcome. Next,
thank you, Caroline.
We have Richard Jefford. Richard is Managing Director with Islands GeoExchange. He's a leading specialist in geothermal, heating and cooling systems. Welcome, Richard.
Thank you.
And next, we will have a shared presentation from Johnson Control with Rob Paul. Rob is Technical Sales Engineer for Industrial Refrigeration. And Graham Marr. Graham is Frick and Sabro Product Specialist for Industrial Refrigeration in Australia and New Zealand. Welcome, Rob, and welcome, Graham. So now, let's start the presentation. Over to you, Michael.
Thank you, and welcome everyone. Today we're going to explore hyper-efficient cooling below the wet bulb by Sealy International. Sealy International are an Australian company founded by Frank and Kathy Sealy in 1972, and our focus is on energy-efficient, innovative cooling and heating solutions. We're head officed in South Australia with our main manufacturing plant here at Lonsdale, slightly south of Adelaide City. We have a second facility up in Albury, New South Wales. We are Australia's largest air conditioning manufacturer, and we are exporting our innovative energy-efficient cooling and heating products to many countries. We also have a manufacturing presence in the USA and have our own sales offices in several countries. In the last 2 years, we've invested $25 million at our South Australian factory. We recently purchased a site in regional New South Wales, and our 35-year-old factory will be transferred to a new site in the same region in the coming years. Our research and development department are designing future HVAC products that may take 5 to 10 years to launch to the HVAC market. We have over 50 engineers on staff, and we aim to be world-class in everything that we do. Our company ethos is innovate, automate, and accelerate. Now we want to explore more closely the Climate Wizard indirect evaporative cooling technology. This serves to illustrate the key to hyper-efficient cooling. Climate Wizard is an air conditioner that uses an indirect evaporative heat exchanger core to provide hyper-efficient cooling. It delivers 100% fresh, cool outside air with greatly reduced energy consumption. We have seen up to 80% less energy usage when compared to an equivalent refrigerated system performing the same duty. The cold air produced by Climate Wizard can be like that produced by refrigerated systems with temperatures that approach the ambient dew point temperature. This is what we call our supercool model, and demonstrates the use of indirect evaporative cooling and direct evaporative technology in the same system to be able to control temperature and humidity. We achieve this by our patented counterflow heat exchanger. And here is a more in-depth look at what happens inside the Climate Wizard. The operation of the counterflow heat exchanger, this is presenting the indirect only version of Climate Wizard. So cold, dry air with no added moisture is supplied into the building. It's first a myth that an indirect system will still have moisture and therefore be ineffective in humid climates. Fact is, for pre-cooling outside air application, we have sold many units into Queensland, where McDonald's restaurants have won environmental awards thanks to the significant energy reduction. But critical for the brand, patrons and staff enjoyed total comfort and a healthy indoor environment. Pre-cooling application. So similar to the McDonald's case study and many other fast food restaurants, the application in this diagram represents pre-cooling outside air, as Climate Wizard is used for the 100% outside air and does not add any moisture to the airstream. It can partner quite comfortably with any DX or refrigerated technology. In fact, it can significantly reduce the size of the chiller system or the refrigerated air conditioning system by pre-cooling that outside air. And obviously, it significantly reduces the peak electrical demand. Standalone cooling. So in the hot, dry climates, we can use Climate Wizard to provide temperatures below the ambient wet bulb temperature, and it's utilising effectively as the sole source of cooling for a space in drier climates. The Climate Wizard only uses an EC plug fan, therefore it is a very efficient source of cooling at part loads. As mentioned earlier, we can achieve up to 80% cooling energy reduction compared to a refrigerated system. And Climate Wizard's Super Cool range, where we introduce a direct evaporative stage after the indirect evaporative core, can achieve very low supply temperatures. In fact, we use this technology in the wine industry in the Barossa Valley, where we can supply air into the space at around 12 degrees and realise a space temperature of 16 to 18 degrees, purely with indirect direct evaporative technology. Supplementary cooling, you can also adopt Climate Wizard in a hybrid or supplementary design. So Climate Wizard becomes part of the total solution, where it takes the lead on the cooling requirements into the building and to meet or even exceed the minimum outside air requirements and to handle most of the base load. Supplementary reverse cycle systems then can be used for trim cooling and also to take care of heating requirements. I'd like to share a few case studies. This is a flyover of a super school in Western Australia, where 60 of our Braemar direct evaporative units are utilised for the classrooms, and 7 Climate Wizards are installed in the library. Evaporative technology was adopted to reduce electrical demand and energy consumption, a cooling solution that integrated nicely with the solar energy systems, and obviously it's improved the indoor air quality, particularly where needed in learning environments. A common control platform was used for ease of operation for the school personnel. And in this case, we're truly exceeding the minimum outside air requirements from Australian Standard AS 1668.2. And the low input power of evaporative-based technology integrated nicely with the PV system that you can see. The second example is a auto group in California. They went through a significant energy efficiency project supported by the local utility provider. And it consisted of a number of solar panels, LED lighting, and nearly up to 800 kilowatts of Climate Wizard indirect evaporative cooling capacity. They're able to reduce their energy demand or electrical demand for their HVAC and lighting as much as possible before sizing the solar PV. And the retrofit achieved 86% energy reduction. The last project we would like to look at is an airport constructed on Shimoji Island. Shimoji Island is a small island located near Okinawa in Japan. The project achieved zero energy building ready status, which means it achieved over 50% reduction in energy consumption when compared to an equivalent baseline building. In total, the project utilised Climate Wizard to pre-cool 170 kilowatts of outside air. The Climate Wizards were funded by an energy efficiency grant from the Japanese government. In addition to those examples mentioned, we have had success in a range of industries. Kitchen makeup air cooling with the likes of McDonald's and Hungry Jack's and KFC, to name a few. Supermarkets, pharmaceutical warehouses, university labs, wineries, office buildings, a number of different applications. Operating Climate Wizard in hot, dry climates, as mentioned, for standalone cooling, and for the more humid climates, predominantly for pre-cooling the outside air load or spot cooling. Over the past 2 years, we've invested heavily in R&D and in a new manufacturing line to produce the next evolution of Climate Wizard. This is utilising microcore to realise our goal of introducing Climate Wizard to the residential market and commercial market. We have focused on compacting the heat exchanger. We've taken the heat exchanger that was 600 mil deep and have produced a heat exchanger that is only 150 mil deep, so a quarter of the size. We have packaged this into what we dubbed the CW3 for residential cooling and CW6S for the light commercial market. The next step for us with the microcore is to adopt this technology into a modular commercial lineup. I mentioned earlier our Climate Wizard Supercool range. This is a combination of our indirect evaporative core and direct evaporative technology. The Supercool range, we can control temperature and humidity. As we introduce a direct evaporative section for reducing supply temperatures even further and adding some moisture to the space. In this current climate, new studies show that there is an optimal band of humidity to maintain a healthy indoor environment. In the image provided, the direct core is shaded in orange. Traditional air conditioning equipment often do not add humidity or do not have humidity control and can dry out the space. And thank you very much for your attention. I'll hand back to Caroline.
Thank you, Michael. Great presentation and great innovative technology. Next is Richard Gifford. So over to you, Richard.
Thank you. So thank you for having me. I'm Richard from Highlands Geo Exchange. We specialise in geothermal heating and cooling. This is for residential or for commercial systems. Our key focus is getting a holistic solution for clients, knowing where the energy is coming from, what we need to deliver and where it's going to be delivered, and how efficiently we can do this. We're extremely passionate about environmentally friendly solutions, which is our primary motivation, driven us towards the geothermal market. Obviously, the next step is moving towards then natural refrigerants within the heat pumps. There's a growing importance, obviously, to get more efficient systems. HVAC, as we've heard through so many other speakers, is the biggest or one of the biggest contributors where we can make the biggest impact, not only residentially, but all the way through every industry. Consumers are demanding better systems, more efficient systems, and they're willing to pay for it. Geothermal in Australia, yes, it's a young industry. It's young because we don't have big market knowledge or acceptance. It's not young in the fact that we've got working examples within Australia that have been working for over 25 years. The Geoscience building in Canberra has got over 200 machines installed, and they've been running for over 20 years within that building, the same equipment. The market in Australia is expected to grow. We are getting big interest again with the world pandemic. People are searching and checking out where they can do things better. With people spending more time at home, they're wanting more comfortable environments. A geothermal system delivers some of the highest COPs in systems. So we're getting on average a COP of 4, giving us a 400% increase on the power consumption for a system, which is making it some of the most efficient systems available. Geothermal, traditionally, we are a low temperature geothermal system. We're using the natural temperatures embedded in the earth. The sun is heating the earth up 1,100 watts per square metre annually in the world. So what we're able to do is that stored energy at 5 feet deep in my region is between 15 and 19 degrees. We use pipes within the ground to extract or reject energy within that stable medium. So we're using the earth as a battery, if you like. We can also use water, the harbour, big bodies of water. There's great examples of airports around the world where they've got lakes nearby, and they're using and extracting all of their geothermal energy from those mediums and body of water. So there is potential to get embedded energy in a lot of different places. And with a geothermal heat pump, it's just complementing being able to extract and reject these energies in a very efficient way. Traditionally, a geothermal system has very low refrigerants within a system. We are hydronically based. So our loops or our rate of extraction and place of extraction is water-based solutions. We're then using those ground loops or pond loops to extract and reject energy. So traditionally you would call those an evaporator or a condenser. On the delivery side, we then have the ability to deliver through traditional methods. We can do it through floor hydronic heating. We can do it through panel radiators. We can do it through ducting, through fan coil units to be able to deliver heating or cooling through those mediums. We can do it through plate heat exchangers for domestic hot water or for pond, pool, spa, or any other medium that needs heated. A heat pump can heat water. It can deliver chilled water from 7 degrees and heat our delivered water to up to 60 degrees. So it's ideal for all of the conventional methods that we currently are using. My search to find more efficient, holistic ways of doing this a few years ago led me to EcoForest. EcoForest is a Spanish manufacturer. These examples on their residential heat pumps, they are what's called a 6-pipe heat pump. So we can actually use 2 cycles from the compressor. So we can do simultaneous heating and cooling at any one cycle through the refrigerant process. So we're gaining a double efficiency through the one cycle. We're able to reject energy and use that energy while it's doing another process. So in cooling, we can be doing hot water heating, we can be doing pool heating, or when we're doing heating, we can also be doing heating in domestic hot water simultaneously through any season cycle that's required on that building or that system. The heat pump as well, they've been developed to be the most efficient they can be. EcoForest impressed me like no other manufacturer when you see their R&D department. I relate this company to the Tesla of the industry. They've taken a blank canvas, they've looked at it, and they've built it from the ground up. They've got smart applications like their VSD drive, variable speed drive, produces a lot of heat. They've actually put an aluminium heatsink and run water through that heatsink to actually use that heated water within their system and process without having to add other features. Traditional manufacturers have used very small cooling fans to try and cool their VSD drive down. So it gives the opportunity of these heat pumps to be installed in higher temperature and climate availabilities as well. So we can install them in roof spaces. Other systems with variable speed can't do that. EcoForest have been building variable speed heat pumps since 2012. They were one of the first to do that within this field. They have a vast array of controls inbuilt to ensure that installation time is kept to a minimum. Within their range of heat pumps, they've also made available within a residential market, traditionally only available in commercial, the ability to do aerothermal or dry cooler connections. So this is where we have a combination of geothermal, the pipes in the ground, or extraction system within the ground or the embodied water system, and we can reduce the size of it and add dry coolers or aerothermal units. This is where we're then using the ambient air temperature at a point in time to either extract or reject energy from. Now, the EcoForest machine will look at the different mediums to extract and reject the energy, and it will either use one or the other or use them in combination. This greatly reduced the installation cost and capital cost for residential and commercial applications, giving them a much higher cost benefit and return on investment compared to traditional geothermal systems that I've been used to dealing with and the industry has been made aware of. EcoForest have just released this last week a R290 refrigerant system. So what they've done is they've taken their traditional equipment and they've produced the first two units they've produced are the EcoAir Pro 3 to 12, which is air sourced, and the EcoGeo Pro 1 to 6, which is ground sourced. The EcoAir Pro is the machine on the right in this image, and it is a monoblock air sourced heat pump. It is using that refrigerant to extract energy from the air and condensing and delivering it to water. And that's either heated or chilled water within the delivery system. The EcoGeo is doing the same process, and again, they're using the R290 in it. This particular machine on the left, the 1 to 6 kilowatt, can produce 6 kilowatts of heating and cooling, and it has a refrigerant charge of only 150 grams. So when you start looking at the grams of refrigerant per kilowatt capacity, they're one of the smallest within the traditional ground source heat pump, but also then when we start looking within HVAC systems as well, making them again more environmentally friendly and more sustainable. A ground sourced heat pump has an average service life of 25 years. They are extremely longevity and efficient within their operation. The ground loop and all of the delivery methods, we want to ensure we've designed everything to be as efficient, matching this equipment design and installation. The next step, obviously, is compliance. We've got new regulation within New South Wales and other states along the regulation of flammable refrigerants and using R290. So we will be seeking these compliance to be able to sell Australia-wide these new equipment. Obviously, it would be nice to see that regulation can be conformed and the whole of the country can actually have a uniformed regulation on these new flammable refrigerants. So for us, we're working hard to look to ensure that we're meeting and exceeding these new requirements and ensuring that it's getting out to market and being available for everyone, this new available equipment. So EcoForest, next, they're obviously continually developing more efficient equipment and better ways to use the refrigerants, and also moving through to the natural refrigerants within the industry. ANZIA is a newly established association, a local ground-sourced heat pump association. I'm involved in this board. It stands for the Australian and New Zealand Earth Energy Association. This is where traditionally I've been trained through an American association, ICHPA, which is the International Ground Sourced Heat Pump Association, based out of Oklahoma State University. It's timed in where they've actually just disbanded this last year. And so this gives us a great opportunity to build a new regulation and association where we can set local standards and have local training and have local support within this industry. So my job is to raise awareness and be promoting this product, selling EcoForest to dealers throughout Australia, advising and making engineers aware of where we can use it. Also developers. I've done presentations to developers where there is redevelopment in cities. This gives an opportunity where we're looking at things like vertical schools, vertical retirement villages, where energy can be shared between building and services. A ground-sourced heat pump can also use the embedded energy from wastewater. Sewer has an average temperature of 21 degrees C, making it ideal that in the planning phase, when we start looking, we can use these embedded energies and make a holistic system so much more efficient when delivering and moving forward in the future. So thank you very much for listening to me. There's been some very great presentations. Thank you very much for your time. I will be answering any questions. So thank you very much. I hope you enjoyed it.
Thank you, Richard. Great technology, and I'm sure a lot of opportunities in the future. Now, we're moving to the next presentation, and it's a shared presentation by Rob Paul and Graham Marr. So, welcome, Rob and Graham. Over to you.
Thanks, Caroline, and thank you everyone for logging on today. As Caroline mentioned, my name's Rob Paul, Technical Sales Engineer for Johnson Controls. I'll be touching on the Sabro R2 propane Sablite chiller, and I'm here with my colleague Graham Marr, who's our product specialist, and he'll be talking about the Sabro ammonia heat pumps. We are in Melbourne, so halfway through the presentation we will be swapping seats for social distancing purposes, so just to let you know. So for those of you who aren't aware of Johnson Controls, we're a global company with over 100,000 employees around the world in approximately 2,000 locations in 150 countries. And we've got headquarters in Cork in Ireland, Milwaukee and Shanghai. So Johnson Controls are a very varied company. This is the lines of business they're involved in, from building automation and control, HVAC equipment, which a lot of you guys may be aware of, the York and Hitachi brands, fire hazard and protection, security with Tyco and ADT. Myself and Graham are in the industrial refrigeration space. We look after food and beverage, Frick, Sabro and York products. We also do retail solutions and power solutions. So the Sabro chiller product range, they range from the chill pack, which is a small compact one on the top left, increasing in size to the pack and the pack screw. And today I'll be discussing briefly the chiller in the top right, which is the propane Sab Light chiller. They also do a freezer chiller, which is the one in the middle, the CAFP. And Graham will be discussing the heat packs, which are the third row down. This is a picture of a smaller Sab Light chiller. It's got the control panel up the front, the condenser and the coils and the fans on the top, and the evaporator, the compressor and the oil cooling in the cabinets below. So as you can see, it's quite compact, suitable to fit on roof buildings, or we've got one, I'll get to it soon actually, here. So Sabro have got a large installed base throughout Europe. We have got one located in CBD of Sydney on top of Legion House. It's been operating trouble-free for about 5 years. That's the only one we've got in Australia at the moment. They have a small refrigerant charge, which will show on the chart on the next page. As mentioned, it's propane, natural refrigerant, future safe, an ODP of 0. Sorry, next slide. ODP of 0, a GWP of 3.3. And this one is important if it's installed on commercial or residential buildings. It's extremely low sound levels from 45 up to 55. As mentioned, it's got a small footprint per the picture there, and it's very compact. Operation-wise, it's got skip-free capacity from 20 all the way up to 100%, and extremely long service intervals, which is important when end users and operators are considering the operating costs. This helps to minimise and lower the operating costs of the chiller. As you can see, it's got plenty of access around for maintenance purposes, for the coils, the fans, the evaporator, and also, very importantly, every chiller that leaves the Sabro facility is functionally and performance tested prior to delivery. So this chart shows the 10 different models that the Sab Light comes in, ranging in cooling capacity from 160 kilowatts all the way up to 400 kilowatts. It's got impressive COPs up to 4.7. And importantly, as you can see there, the propane charge varies from as little as 24 kilograms all the way up to just under 60 kilograms, or 56 kilograms for the larger unit. And the dimensions are there, 1.25 metres wide up to just over 10 metres for the larger unit. And what happens in case of a leak? There's a few safety functions. It's got a gas alarm in the control cabinet. It's got a ventilator, and it's got the gas detector mounted underneath the coils. There's also a vent pipe which vents the gas to a safe area. At 5% LEL, the ventilator starts and the cabinet's ventilated. At 15% LEL, the motor and expansion valve are cut off. And at 25% LEL, all electrical equipment, apart from the ventilator and gas detector, are shut off. So that's a brief overview of the Sab Light. I'll now hand over to Graham, who will discuss the heat pumps.
Good afternoon, everyone. It's my pleasure to introduce you to the Sabro low-charge heat pumps. Most sites reject heat into the atmosphere through cooling towers. So why not reclaim this heat to heat hot water instead of throwing the heat away? We have low-charge heat pumps for supplying temperatures up to 60 degrees, 90 degrees, and 130 degrees, but this is done on a case-by-case basis. The water side has to meet most criteria when you're selecting these. When considering heat pumps, it's good to look at the time interval you want it to heat the water, the capacity you need to build peak loads, and what the temperature lift is. For example, from 15 degrees to 60 or 35 degrees to 90. We also, if you're heating from a source of 20 degrees, you'll need a two-stage plant, and this is what we call the dual pack, which has virtually a cooler, a water chiller, as well as a heat pack built onto the same skid. What is a low charge? The minimum charge of ammonia that is needed to design heat capacity, and that is our heat packs. 140 kilowatt would only take 20 kilograms of ammonia, and 1,100 kilowatts is roughly about 50 kilograms of ammonia. We did a case study just to give you an idea of what the payback would be between gas boiler and a heat pack. And we looked at the gas cost and the heat pack running cost, and we ended up with a payback period of 4.1 years. So in summary, the ammonia heat packs can do capacities from 300 kilowatts to 12,500 kilowatts. They're a low charge, minimal ammonia inventory. We have a global warming potential of 0. We can heat hot water to 90 degrees and up to 130 on a case by case. This is a new technology that is just about to be released, and a COP of 6.5 heating only. These, oh crikey, I haven't, I'm sorry. These applications are used in the meat and poultry industry, the food and beverage, the dairy industry, and the leisure industries. And you can go to the last page. We have any heat pack that Sabro produce is tested in what we call our end-of-line facility in Denmark, and they run for about 4 hours under the maximum conditions, and you get a full report of them at the end. So thank you very much for listening to my brief presentation, and we're open for any questions.
Okay. Well, thank you, Rob and Graham. That was a very interesting presentation. Okay, so let's move to some question. I didn't see any question coming. Let me check. No, there is no question. Well, I have a question for you, and it's an open question. So I would like to know if COVID-19 has impacted, the industry, your business, and do you think that the recovery post-COVID-19 will foster, the adoption of this new technology? Who would like to answer? Maybe Michael?
Thanks, Caroline. We're in the business of residential cooling and heating as a significant commercial range of products. We've seen COVID-19 have an impact on our residential sales because a lot more people are working from home, especially in the Melbourne market. We sell a lot of residential natural gas heaters, so we've seen a very strong uptake of that technology. From a commercial perspective, we're seeing a lot more inquiries for climate wizard indirect evaporative cooling, especially the supercool with the direct evaporative stage. So now people are starting to look at their buildings to see whether they are in the right area for humidity control. And obviously with our supercool model, we can obviously control temperature and humidity and add a little humidity into the space, which is more desirable at the moment.
Okay, thank you, Michael. Now, I think we've lost Rob and Graham. I don't know if they can hear us, but we've lost them on camera. Oh, they're back. Excellent. Okay, now a question about heat pump. You know, in preparation of the conference, I sent you an article about Elon Musk seeking to build a new HVAC system for the home based on the new heat pump system designed for their newest, Tesla Model Y. So what do you think about that? Richard, would you like to answer?
Yeah, look, I think it's very positive that we're getting someone who's so good at marketing, bring HVAC to the forefront in everyone's minds. Very interesting to see that he's going down the HEPA filter area. I think that's exciting. Most conditioning systems, air conditioning and everything else, engineers will tell you, and suppliers, most systems are available to adopt up or add in a HEPA filter system to most traditional systems. So I think it's good if we can make some awareness about what filtration we need to be looking at due to the COVID-19. How can we clean the air and where is it best used? So that's probably my biggest take on what that article produced. And the HVAC industry has been producing unique heat pumps for a very long time. So that's the biggest thing that they've been able to do is filter the air very well. Obviously, he's going to market the system very well as well. Heat pump in an electric car just makes sense. Other car manufacturers have already been doing it. Hyundai have had a heat pump in their car for a while. So it's a natural progression to ensure that they're not using a direct element for their heating or things like that. So, yeah, that's what I think.
Thank you, Richard. And I have a question for Graham. So you're using hydrocarbon and ammonia, which are the two natural refrigerants, that are often, looked as they are, toxic or flammable. What do you think are the main barriers, for the industry and the market to adopt this technology faster?
Well, I think that there is two things there. There's a lot of refrigerants out there that are potentially flammable already. From an ammonia point of view, you could argue that you soon know that most ammonia plants are built very high, and we haven't experienced a lot of situations where people are experiencing leakage. But also, one of the reasons Sabro developed a low charge ammonia system is so that they kept the gas charge to a very low level. And from that point of view, we think that it's relatively safe. I know that there are ammonia heat packs used in the centre of London on top of buildings. In fact, there's one not very far away from the London Eye. So we think that as time goes on, people will get more used to this, and there are various things we can do to minimise the risk. For example, using ammonia scrubbers, for example, using alarm system and keeping the charge low. The same can be said for the propane chiller. Again, it is a very low charge chiller, and it also has leak detection on it to take care of that. And the Sablite has the compressor and evaporator all built in a cover that has a air induced by a fan that is controlled by the leak detection system. That's connected to a pipe that's taken to a safe ventilation point. So to a large extent, I think that these systems can be integrated into our modern requirement as time goes on and the need for natural refrigerants grow.
Thank you, Graham. I would like to thank our panel, and it has been an incredible conversation, with a lot of new and innovative technology, which have a lot of opportunities in the future. So thank you to all of you. Stay safe, and I'll speak to you very soon. Thank you.